Start with Unit 3 today. Unit 3, the first topic is injury and inflammation. We have already understood that whenever there is a damage to the tissue, our body reacts, our immune system reacts in a process called inflammation. Before we talk about inflammation, let us understand what do you mean by cell injury or injury to the tissue. Any kind of stress that the cell encounters due to any kind of change in its internal or external environment, we call that as an injury. And depending on the type of injury, the cells have different ways to adapt themselves. For example, you can see here there are different causes which different ways how the injury can happen. It is not necessary that always a physical injury is only called as an injury. It can be because of an oxygen deprivation or because of certain chemical agents or immunological reactions. Any kind of damage to the tissue is called as injury. And all this will lead to an immune response called as inflammation. And the degree of inflammation, based on the degree of inflammation, you can classify inflammation into two broad classes called acute and chronic inflammation. Right? So in whichever way, whenever there is a damage, the tissue tries to adapt itself to come back to the state of normalcy. And this is called as cellular adaptation. You can see there are different types of ways how the cells try to adapt. For example, hypertrophy, where the cells increase in size, which leads to overall increase in the size of the organ. Or in certain cases called hyperplasia, there is increase in the number of cells. Or in certain cases there is reduction in the number of cell or the cell size, which leads to reduction in the size of the organ. Or metaplasia, where there is change in the cell type. One type of a cell is temporarily changed to another type of cell to survive a certain situation. So these are called as cellular adaptation. And all these cellular adaptation can lead to different types of outcomes of inflammation. It can be either resolution, where there is a clearance of all the inflammatory cells, but then damaged tissue can be seen. Then it can be abscesses, where there is formation of pus, which leads to a change in the color of the tissue or swelling and redness, etc. And finally, repair, where the complete damage is removed and new tissue is formed. This we have already studied under tissue engineering, right? So all these adaptations will happen after the inflammation process. The word inflammation has come from the word called inflame, which means to set fire, because you would have felt whenever there is a damage, that area you will feel one kind of heat or very burning sensation. So that is nothing but a dynamic response of the vascularized tissue to injury. And it is basically a protective response or a defense against any kind of foreign body which is coming into the tissue due to injury. So how will you define the process called inflammation? Inflammation can be defined as a local response of our tissue to the injury due to any kind of agents. It is our body's defense reaction which leads to elimination or limit of the spread of the injurious agent. And the reaction of the tissue to the injury can be classified or characterized as clinically, if we need to characterize it, we can see heat, swelling, redness, pain, or loss of function. Pathologically, different characterizations are there, like vasoconstriction followed by vasodilation, where there is increase or decrease in the blood vessel size due to the pressure flow of the blood. Then hyperemia, where there is an increase in the blood flow to different areas of the body. Then accumulation of leukocytes, exudation of the fluid, that is flow of the fluid from the blood vessel into the tissue, and deposition of fibrin, which leads to blood clot. And these are some of the reasons which leads to injury. We have already seen this. And here are a very beautifully represented picture which shows the various cardinal signs of inflammation. And here is a man whose one leg you can see has chronic inflammation. So overall, if you have to classify inflammation, as I have already told you, you can broadly classify it as acute inflammation and chronic inflammation. Acute inflammation is usually for a very short duration, and mainly neutrophils are involved, whereas chronic inflammation is when the inflammation is sustained for a very long time and very painful, and here usually lymphocytes and macrophages are involved. And usually chronic inflammation leads to fibrosis, clotting of the blood, and formation of a thick tissue. Other than this, we also have another type of inflammation called granulomatous inflammation, which is a type of chronic inflammation. The only difference is the type of cell structure that is formed. Based on that, we have given the name granulomatous inflammation. We will talk about this in the later slides. Okay, so let us talk about acute inflammation. The two major events of acute inflammation are vascular events and the cellular events. Vascular events are related to the vasodilation or vasoconstriction, and cellular events are the where the immune cells come to the site of injury. So edema is a very general terminology which means swelling, and that edema is caused because of a dysregulation of the hydrostatic pressure. The pressure which makes sure that whatever fluid is leaking out of the blood vessel enters into the blood vessel in the normal tissue. But when there is a damage to the tissue, there is dysregulation of this osmotic hydrostatic pressure. Hence the fluid will only go out of the blood vessel and will not come, the balance is not maintained, it will not enter into the blood vessel. This leads to a swelling of the tissue, right? So let us see how the leukocyte extravasation takes place. Leukocyte extravasation is nothing but the leukocytes, from the blood vessel, they will come out and enter into the site of injury, where they will carry out phagocytosis. So let us see how this extravasation is taking place. So overall, if you have to define the process of extravasation, we can call it as delivery of leukocyte from the blood vessel or the vessel lumen to the interstitium, to the tissue at the site of injury. What is the job of these leukocytes? Leukocytes' main job is to ingest any offending agents, that is through phagocytosis, or they can kill the microbes, or they can degrade any kind of necrotic tissue, any dying tissue, or any foreign antigen. This is what the leukocytes are going to do once they come to the site of injury. This process of entry of the leukocyte from the blood vessel to the site of injury through the process of extravasation is divided into 4 stages or 4 steps. The first step is margination, rolling and adhesion of endothelium. Margination, rolling and adhesion means when the leukocytes which are present in the blood, they will go and attach themselves to the internal wall of the blood vessel. From there, they will, next step, they will pass through the blood vessel, enter into the tissue. This is called as diapedesis or transmigration across the endothelium. Then the third step is migration towards a chemotactic stimuli. We have already understood whenever there is inflammation at the site of injury, your immune cells, they will start releasing certain chemical molecules which will act as chemoattractant, which will attract immune cells to the site of injury. This is what is called as migration towards chemotactic stimuli. And finally, phagocytosis, which we know is the engulfment of these any foreign particle by the leukocytes like macrophages or B cells, and then processing them and presenting them for further activation of the immune cells. So here is a diagrammatic representation of the entire process. You can see here the pink portion is the blood vessel and the bottom blue portion is the tissue. So you can see here the leukocytes, they attach themselves in the first stage, migration, rolling and adhesion, through 2 important proteins which are expressed on the surface of the blood vessel, inside surface of the blood vessel, called P-selectin and E-selectin. After the binding, the leukocytes, they will express the chemokines which will enter into the tissue. And then we have already understood cell ECM interaction takes place through integrin. So here also you can see the integrin which are expressed on the surface of leukocyte. They will bind with the integrin receptors present on the ECM molecule, and through that the attachment is taking place. After that, the cells will transmigration will take place, and they'll enter into the site of injury, where they will be attracted to the site where there is an injury through the chemoattractant, and then engulfment through phagocytosis or endocytosis will lead to removal of any kind of foreign particle. So this is the entire inflammation process. And what kind of outcome can be seen in case of acute inflammation? Complete resolution. Abscess formation is the formation of pus, and fibrosis, where there is accumulation of the fibrin, that is the clot-like structures. And finally, if it does not resolve, it will enter into chronic inflammation. And chronic inflammation is same inflammation, but it persists for a very long time. Severity of inflammation is very high in case of chronic inflammation. So here are some of the types of acute inflammation, patterns of acute inflammation that we can see. First one is called as serous inflammation, where there is outpouring of very thin fluid. In case of blisters, you can see. Then we have fibrinous inflammation, where there is formation of fibrin, that is scar-like tissues are formed. Then we have purulent inflammation or suppurative inflammation, where there is pus formation, lot of pus formation or abscesses formation. Then we have ulcer, like we have seen within the mouth, you will see small ulcers. Those are the local defect on the surface of the tissue, right? So these are so this is a serous inflammation. Then this is a fibrinous inflammation. Then these are the abscesses formation, and these are the ulcers. So these are the different types. Then coming to the chronic inflammation, as I told you, it is same as acute inflammation. Only difference is it persists for a very long time, and this type of immune cells involved are different. So here is a list of major immune cells which are involved in chronic inflammation: lymphocytes, macrophages, eosinophils, and mast cells. This is a table which gives you the difference between acute and chronic inflammation. Very, very important 2-mark question. Please learn it carefully. Then the time course, as I have already told you, acute inflammation is for a short period of time, whereas chronic inflammation is for a greater period of time, as well as the cells involved are different. In case of acute inflammation, it's only the neutrophils, whereas in case of chronic inflammation, we have lymphocyte, macrophages, and other types of immune cells like B cells and mast cells. Then coming to the third type of inflammation called granulomatous inflammation. It is same as chronic inflammation. The only difference is in case of granulomatous inflammation, the number of activated macrophages are very high. All these activated macrophages, they clump together resulting in formation of a mass tumor-like structure called as granuloma, which is a multinucleated mass of cells made up of activated macrophages. That is why these are called as, this type of inflammation is called as granulomatous inflammation. Okay. After this, all this we have already seen. Increased blood flow, which leads to redness and warmth, heat generation, then there is swelling, and then there is loss of function. Right? So this is what we have seen. First is vasodilation, then you have edema, that is swelling, then the exudation of the or extravasation of the leukocytes, migration and chemotaxis, and finally you can see the same thing in a different diagrammatic representation. Then we have different types of chemical mediators which are involved. The major one are the histamines produced by mast cells during vasodilation. Then we have prostaglandins, which are the major reasons for causing pain and fever, and these are produced by all nucleated cell. And finally we have the bradykinins, which cause the pain, and these are also released by the mast cells. Then other types of chemical mediators are listed here. It is enough if you remember these three major classes, right? Then we have certain chemical changes which we have already understood. Outpouring of albumin-rich fluid, which leads to thickening of the blood, and then because the liquid portion of the blood goes out of the blood vessel, leading to increase in the viscosity of the blood. Right? And in case of acute inflammation, neutrophils are the major ones which get activated. And as I have already told you, the damage can be either it can last for 15 to 30 minutes or it can go up to more than few minutes. Then here are some of the terminologies associated with inflammation. Edema, excess of fluid in the interstitial spaces. Transudate, it's an ultrafiltrate of the blood plasma. Exudate, it's a filtrate of blood plasma mixed with inflammatory cells and cell debris. Pus is a purulent exudate. And phagocytosis is the final step of inflammation, where the leukocytes will ingest the foreign particle and process them. I will not explain it here because we have already understood what is phagocytosis. Then these are the various outcomes which we have seen initially itself: abscesses, ulcer formation, or fibrosis or scar formation. Or it can, if the damage is too much, it will lead to chronic inflammation, where fungal or viral or other kinds of molecules might be involved. These are some of the terminologies which are associated with inflammation, medical terminologies associated with inflammation. Carbuncle is an extensive form of abscesses where pus is present, too much of pus is present. Then we have, I am not showing you the diagram because to see it looks very, yucky. So I am not showing you the diagrams of these. Then you have the furuncle or the boils, which are filled with lot of pus overall. Then cellulitis, where there is lot of thick tissue formation. With that we complete injury and inflammation. Thank you.